Test, test. Does it work now? Who knows? Test, test. Test, test. I think it works now. Think it works now? Yeah. What? Why? Yeah. What? Why? What? Why? All right. Not a great start, but we'll take it. All right. Why did that happen? I don't understand. Okay, so let's play that background music. Let's see. I think it now works. Let's see. Hopefully it does. I think I just tuned into the live stream and it works. I changed nothing. I changed absolutely nothing. I just restarted OBS. I don't understand what was going on there. All right. Cool. Thanks for joining and finding the live stream. I'm just going to post quickly on Twitter that we moved the live stream. All right. Unfortunately, it's not possible to resume a live stream. Otherwise, I would have continued watch on the other one. But anyway, I'll just tweet real quick and then we will get to actually solving the challenge. So, unfortunately. Okay. All right, cool. So I tweeted about that. Maybe I can quickly comment on the other one that it moved. Technical difficulties. So we have to move to this one. Okay, so now let's open the Advent of Code website again. Hopefully we'll still have enough time. Okay, so let's go. Hopefully now everything's gonna be okay. Okay, so basically, I'll start over. I won't read the whole story. If you're interested, basically they have this like preamble that's kind of setting up the story, but basically, actually, Rick, now that you're here, thank you so much for letting me know. I would have gone on and done the entire episode if you hadn't said something. I don't know what was wrong. I just restarted OBS and everything worked. Unfortunately, it's not possible to resume streams, so here we are. Anyway, so like I said, the way that Advent of Code works is that there are kind of 2 challenges every day that need to be solved, and then you get, you know, you need to solve the first one in order to get the second one, and I think you can then kind of go through all of them. There are 50 challenges in total until December 25th. They have this nice story over here, but which I already read once on the first try of the stream. But basically, the first challenge is we need to read some input line by line, and we need to find the first and last digit on that line, the first digit and the last digit. And together they then form some decimal number. So we've got 1 and 2, so 12 on the first line, then 3 and 8, that's here and here. The next one is kind of interesting, 1 and 5. There are actually multiple numbers in here, but it's only the first and the last. And then the final kind of interesting one is where there's only a single number, and that one is then used twice. So that's what we need to figure out, and there is some puzzle input over here. So we'll download that for ourselves. Maybe there's an additional interesting one if there's nothing. I suppose then we just use 0. I guess that should be the correct input then. But yeah, we'll start with that. Let me put the preview on one more time while I set up my development environment real quick. And if we have enough time, maybe we'll try to do some performance optimizations. That was actually the intention, but I think maybe today that's going to be a little bit tight in terms of timing. So now let's go back. So we've got our scene. I already copied the challenge. So we need to download the input. Oh, bad request. Okay. Let's go back then. All right, so we'll write a quick main function in Go. And I guess, you know, we'll start with just reading all of this into memory. So we have a buffer. And let's start read file input. And then we'll do something like result. All right, so this is what we'll do. And then we'll return some integer and an error. All right, so we need to go over this line by line. So what we're gonna start with is we're gonna use a scanner from the buff.io package. And then we scan and we, what was it? The challenge again. So we scan line by line and we find the first and last. All right, so, and then we sum it. That was the we needed to do. to process line. I suppose if it's two numbers, technically, we can represent that as a single uint8. Yeah, so let's not make our lives hard to begin with. Let's start with just making this a uint64. All right, so maybe it's nice to kind of do this half-half so we continue to see the challenge. Let me know if there's any other way that I could kind of make this easier for y'all, or if this is not helpful, just let me know in chat. I suppose we could just make it an int. It doesn't really matter, I suppose. This is we're summing data, and so we're just giving ourselves another bit to work with. But you can probably do just an int as well, doesn't matter. All right, so we'll process a line. So we'll do find first digit. Sorry, first digit. This will be a byte. Okay, find first digit, line, and last digit, and last digit, line. And then we'll do find first digit, line, byte. And this will return a byte. And last digit. And then what we're going to do is to get the number is what we're going to do is we're going to do some math here basically. So we're going to do uint64 of first digit minus 0. Yeah, exactly. I don't know what this is going to do, but last, and we're going to multiply that by 10, and we're going to then add uint64 last digit. Yeah, exactly like this. So what we're doing here is we're basically converting the character in ASCII. So this is some offset, of course, but because this is just a single byte, what we're doing is we're basically normalizing this so that you know, whatever the offset is, 64 or something. I don't remember what it is, but let's just assume that it's that. We're normalizing that, and since this is the first digit, we want to multiply that by 10, because then we get, you know, in this case 10, in this case 77, and so on. So something that we're going to need to do in this function in particular, but in both, I guess, is we need to return 0 if there is nothing, because then 0 times 10 is still nothing. So, all right. Maybe we can actually also write a couple of unit tests before we continue. Maybe we should have done that at first, but we live in there then. So test process line. And we'll do some tests and we'll have no, we'll just have an input string, and we want some unit 4. Rick saying, I love this. I like completely different than my approach, and I'm here for it. Awesome. Yeah, that's exactly what we want to do, kind of just see what we all come up with. All right, so input, we'll start with 1 ABC 2, and we want 12. Let's see how quickly Copilot picks up on PQR3 STU 8 B X. I knew it on the second try. Yeah, Matthias, we need to figure out how to resume streams, if that's even possible. I have no idea. But it's happened a couple of times that we had some sort of technical difficulty and then couldn't resume. Okay, here, this is interesting. Matthias says, I'm not sure it's possible without some in-between service. Yeah, I was afraid of something like that. All right, so input trip 7UCAT, and then we'll add one more input test, and we want 0. All right, cool. So now we do this and then add. Okay, cool. Happy with that. All right, cool. So all right, so now what we're gonna do, and hopefully GitHub Copilot doesn't autocomplete it too quickly. We want to find our first digit. So I think the easiest way we're gonna do this is just a for loop. Yeah, and exactly this is what I was gonna do. If it's larger than or equal to 0 or smaller than or equal to 9, then we found our digit and we can return that digit and we're done. And for the second one, for finding the last one, what we're going to do is we're going to just do exactly the same thing, but we're going to do that in reverse. So I'm going to copy this and we're going to start with len line -1 while it is larger than 0, and we do exactly the same thing. So now I think we already have everything we need. What we still need is whatever, like this, when we don't find something. Thank you, Matthias. Of course, I minus in this case. All right, I think process line is done. Let's just run our tests here. Okay, go mod init, go mod tidy, and go test. Result declared but not used. I assume that's in this. Okay, we then do that. Right, that. And then 33 process line returns 2. Sorry, assign mismatch 1 variable, but process line returns 2 values. Oh, these are main, I'm sorry. All right, so, okay, we wanna, okay, then let's rewrite this a bit. We never want an error. Pay toll. And here we want to do this. Okay, so our test passed. So now let's complete this. So now what we want is value and error of process line bytes. Yep, that looks good. We do not want an error. Oops, what's that doing? We'll return 0 error. And we just do result plus value. All right, cool. I think we're already done. So, okay. Now, let's see if this is correct. That's not the right answer. Your answer is too low. Okay, so what are we doing wrong then? First digit and last digit in that order to form a single 2-digit number. Adding these together produces 142. Let's make sure. Okay, we have 1,000 lines. That seems not by accident. Hmm. Hmm. What are we doing wrong? So we're reading the whole thing. Then we are scanning line by line. And our process line passes our test. Hmm. Let's just double check that our tests are correct. So let's say if I put this, put that. Okay. Hmm. Hmm. Okay, let's. And by default, defaults to scan lines. Okay. Let's make sure that this thing isn't erroring. Hmm. What did it say again? That's not the right answer. Your answer is too low. If you're stuck, make sure you're using the full input data out there. Also, some general tips on the about page, or you can ask for hints on the subreddit. Let's see. Let's just double check this again. Just making extra sure that we have the correct input. Hmm. Okay, I guess the only thing that I can think of is let's... Oh, what's this? That's not right. Okay. Okay, so let's add a test case for that. Yeah, okay, I already have an idea of what this is probably gonna be. This must be here because we did... okay. And now this should pass, and now... Aha, that is the correct answer. All right. Let's clean this up a little. Okay, so that's part 1. Maybe we can move everything. Now we do part 2. Oops. Okay, so that's the correct answer. You are 1 gold star closer to restoring snow operations. Part 2. Part 2. Your calculation isn't quite right. Looks like some of the digits are actually spelled out with letters 1, 2, 3, 4, 5, 6, 7, 8, 9. Also count as valid digits. Equipped with this new information, you now need to find the real first last digit on each line. For example, 219823. ABC 1, 2, 3. Okay, I get it. In this example, the calibration values are 29. Okay, we'll copy our part 1 then. Okay, so let's just run this one more time. Okay, so let's adjust our tests then. We'll do 2, 9, 8, 2, 3. Actually, let me just copy this. All right, so input tech. 1, opening parentheses blah. Okay, so now it's 2, 9, 8, 3, 1, 2, 3, right? Yeah. 2, 1, 4. Okay, interesting. Even if they're okay, so Now, 4987. Oh no, there's a 2 at the end. Okay, so that. So C1. Okay, so this is that, right? 14, yeah, and 7, 16. Okay, so 7, 6. Of course, that will fail at the moment. Pretty much every single one, yeah. Okay, so now let's think about how can we solve this. So I think, of course, our general approach still works, but we'll need to adjust our process line. So I think what we can do is I guess the naive thing is kind of we continue to do this and then we compare it with the largest or with the lowest and largest indices of written out numbers, I guess. Would that do the trick? I believe it would. Okay, then we'll rename this to find first decimal char. And instead of returning that, we're gonna return -1 if we didn't find it. And we'll return that now. Okay. I will do the same one for the last thing, and then we'll. I think this should work. Okay. And last decimal are. And now we do find first digit line. Is that what? Yeah, I guess we can do it this way. And we'll decimal index. And we'll also do what will do here? Say that word index. I don't know if that makes any sense, but find first word, first digit word. And what we're gonna do now, this is not gonna be particularly fast, but we'll just start with this. What we'll do is find first digit word. And we'll declare words, digit words, that are mapped to byte. I think. Let's see how it goes. So we'll do 1, 1, 2, yep, exactly like this. Is there what about 0? It hasn't changed. Is there 0? Okay. That does not exist. Okay. We'll just leave it at this then. So our line input. And what we're just gonna do is basically do this and for yep, if byte yeah has prefix exactly yeah exactly that's what I wanted to do. Cool. Alrighty. Return I and otherwise return -1. And we're gonna do the same thing backwards. So again, length line, oops, -1. I equal to 0, I minus minus, and I last digit word. All right, I think that is it. All right, so now in either case, we always still get a byte back, so we still can do this. So, however, so first we'll do the case of nothing was found. So decimal char index equals -1 and word index -1 will return 0. If decimal char index -1 and then word index not -1, then we are going to all right, we're already returning. No, we then want to This is... maybe we want to return two things here. We want to return that and the byte directly. So we return digit. What's wrong with this? Probably. So word index and digit. No, doesn't matter. All right, so that now if decimal char and and this is equal to 1, then we just return line minus that. No, we just return this because we do that over here. Okay, so what case have we not covered if both are not -1? So that's where we've arrived now. Both found. So now we want to figure out which one is the smaller one. So if decimal char index is smaller than the word index, we return that, and otherwise we return digit char. All right, I think that's it. Now we need to do the same thing for find last digit. So find last digit line byte. Now, okay, I don't want to generate it, so I will do decimal char index, and we want to find. We're just gonna copy this basically and just replace it. Last. Replace that with last. So that is the same. I suppose this is the same as well, right? If we can find it. Okay, we need to fix that. Shit. Okay. Now we can go back again. So now we wanted the other way around. So again, we do if found. So we want to pick the first one with the lower index. Both found, so we want to pick the last one, the one with the higher index. Now, so if decimal index larger than word index, return that, and otherwise digit char. We have something now. Oh, interesting. Why did I do that? Okay, we've got something. Let's see. Okay, it passes tests. Who knows? Is that correct? That is the right answer. 1 gold star closer to restoring snow operations. We have completed day 1. So now the question, of course, is, can we do this any faster than what we're doing right now? And to figure that out, let's actually turn our main into a benchmark. So now we don't care anymore. So we use solve. Okay, so we also read this. Yeah. Then we reset the timer, we report allocations, and we run it multiple times. That's all. All right, so let's see. Go test run. We ignore our tests and we just run all of our benchmarks and we see what happens. All right, so we've got 2 allocations. Let's add some CPU profiling and some memory profiling. And let's run this a couple of times. That was pretty fast, so let's run that 10 times, let's say. Now, and we do so. All right. Let's see. And let's say we'll give ourselves 20 minutes to continue to optimize this. We've done the challenge, we've completed the challenge. Now let's just see how much better we can do it within some amount of time. So we'll upload our CPU profiling data. So it's basically currently all being spent in finding the words. And something that is quite obvious, I would say, is string to byte slice. This is one that we see a lot when we optimize. So let's fix that. So that's this one. So the way that we fix that is that we actually, I think I'm not gonna do it the way that I would usually, which is using basically unsafe to do a casting. But instead, what I'm going to do is I will change. So something else that we saw over here is that these map iterations are also taking a lot of time. So the way that we're gonna do, that we're gonna improve this is that we're just not going to make this a map, because there's nothing about this that actually requires this being a map. So what we're gonna do instead is we will make this so. And of course, oops. No. Okay, so this is what we're gonna do instead. So we when we do this, and yeah, exactly. That is exactly what I wanted to do. And then we don't need this. Oops. And we're basically just gonna do the same thing, I think. Digit words. J, that, like that. Okay. Test still passing. Test still passing. So now, gonna run this. I think that already looks a bit better. Let's compare that. So we're already quite a bit better. Happy with that, of course. But let's see what's next. So the next thing we can see is has prefix. Okay. All right, so basically now it's that we're doing all these, how could we improve this? I guess one way we could continue to improve this is what if we by the way, where are the allocations happening? We see 2 allocations happening. Let's fix that first, or let's see what that is. Ah, okay. Okay, I can live with these. Never mind then. So yeah, let's see. So what we could do, instead of looking at the full prefix, is okay, before I'm gonna do any drastic changes, actually let me just commit this. I haven't actually created it in it. just git reset new txt okay, so just gonna get the shell commit before I do anything crazy. I want to make sure I save my result. All right, so what we could do, I think this is quite a bit more complicated, but basically, if we look at the words, if it's O, it can only be followed by 1. If it starts with a T, it should only be followed by these, and so on. So we basically don't need to look at any character that's not O, T, F, S, E, or N. So it's almost like a tree, I guess. So we're gonna do, what we're gonna do instead is like is word is cricket word byte. If so, we'll return something. Then we can probably remove this, but we'll worry about that later. Okay, so what we're gonna do is we're gonna do a switch case. Sorry. So 0 if we're gonna return that. So if that is O, and if not, then return 0. If case is T, we're gonna do 2, 3. If case is F, we're gonna do 4, 5, or 0. What are the other ones? So the next one is S. 6, 7. E must be 8 or it's 0. Whoops. And N must be 9. Default is return 0. All right. Although I guess yeah, I guess it doesn't matter. Okay, so what we're then gonna do here is not has prefix. We're gonna use line that and what did we call it? is digit word. Char if that is not that. Oh, and we don't care about this. And we return C. I think this is it. We'll see with our unit tests. All right, cool. So let's do that again. Cool, I think that looks better again. Welcome back, Matthias. I think the profiling is going pretty good. Here is our comparison. Whoops, bench stat. So from our original solution, we've improved by 93%. So we're about 20 times faster. Let's see what else we can do. I suppose we should double check that. We should add a test. I think this was, yeah, this was the, we should add a test. Test full. Expected. Yeah, not B, I know. Okay, here it goes. Okay, anyway, so we ran our benchmarks. Now let's see if there's anything else obvious that we can have a look at. Okay, so is digit word is now where we're spending our time. So it's not the has prefix anymore. So at this point, we would probably, so I'm gonna guess, we can have a look at this in a second. I'm gonna guess that this now spends the majority of its time in the switch statement. So let's have a look at that. I deleted it. No, I didn't delete it. So the reason I'm gonna pull up this is because in this particular case, our source viewer feature doesn't work yet. We'll get it working, no worries, but it doesn't work yet. So what I want is this. And we want to see, sorry, where did we say it's spending its time? Is digit word. It is digit word. I suppose an optimization that we could do, but as we can see, the majority of time now is spent in this switch. What we could now do is, you know, wherever there are multiple branches in these, but they're not hit that often anyway, we could do, you know, a single character match that for the next one. But I think I'm pretty happy with where we're at. There's one thing that I would like to try, which is I would like to try, you know, we ran this already. Let's rerun this one more time. And we're gonna try putting this through profile guided optimizations. I'm not sure we're gonna get any improvement out of that, but you know, we'll see. I'm not 100% sure, but we'll try. So the way we do this is using the PGO flag, and we're just gonna pass it the previous profile guided optimizations. Sorry, the previous profiling data. And so, wow, actually that is quite a large improvement, I would say. Actually, I'm gonna run this with and without again. So we've got a new PGO. And then I'm gonna run this one more time without. Just so we can compare the difference. And remember, what PGO is. PGO is profile guided optimization. So basically the way that we can think of it is, because we're giving the compiler profiling data about how our code is being executed, it can make better decisions at compilation time about which optimizations to apply, because it knows how this code is going to be executed. And so, as we can see, this is definitely pretty powerful. So without profile guided optimizations, we already improved by 93.32%. With profile guided optimizations, I mean, this is already a very high number, so getting higher is pretty difficult. Because, you know, we're at this point somewhere between, I don't know, 18 times better to 20 times better. But what I think the more interesting thing to see is, what is this different? And so this shows that we're getting a 10% improvement by adding profile guided optimizations. We've done nothing to this code, right? There's no difference in the code. We've only given the compiler some additional data so it knows when to apply which optimization. So I think that's pretty amazing. And as you can see, that's about 15 microseconds that we're shaving off there just by doing this. No code changes. I think that's pretty cool. And profile guided optimizations has only just kind of landed in the Go compiler, so this is only going to get better with time. All right, I think with that, I'm pretty happy with where we landed. We finished all of the Advent of Code challenges for today. We've done some optimizations on them, and you know, I'm pretty happy with where we got. I think ultimately the digits thing is where the most CPU time is being spent. So if we wanted to optimize further, this is where we would need to maybe even think of entirely different ways of how to solve this. Ultimately, of course, we could open the entire box of things like SIMD, right? To figure out which characters could be starts of words and then only check those, things like that. But that's kind of out of the amount of time that we have for today. But maybe in a future episode we'll be faster and won't have any technical difficulties, and then we can maybe look at using some kind of vector intrinsics to solve some of these problems. But with that, please like and subscribe. It super helps us to gauge how much you're liking this content. And happy profiling, and see you next time. Hopefully you have a wonderful rest of your day, and then soon hopefully a wonderful weekend. Thanks for tuning in. Bye bye.